Hi, my name is Jonas Gernitz and I'm going to present my code for the finals of CSC578. This is a presentation of my recurrent neural network that is going to predict temperature. You see in the content you have the imports, exploratory data analysis, normalizing of the data, reshaping the data frame, adapting dimensions for the neural network, and also I'm going to present my best performing neural network model and some analysis. To begin with, this is the import where I import my libraries, the most important ones. And here you have the when I'm importing it as a data, pandas data frame. I'm checking for zero like missing values, which were 0 when I looked for it. Here you can see that I'm deleting the data time feature from my data frame, but I'm also using that to change it to the format of data time which pandas is offering, and I'm adding that to the index instead of the originally index. Then I do some exploratory data analysis. Here you can see the different shapes of the training and test data. Here you can see some descriptions of the features here in the training data set, and here in the testing data set. You can study the mean, the standard deviation, median of some variables, and so on. Here you can study the variation and the fluctuations of some of the variables that I thought was really interesting to study. I also did a lot of histograms to visualize the distribution of each of the features. Where you can see that some temperature has normal standard normalization, normal distribution, meanwhile others do not have that. Then I started changing the data by starting with normalization. I used the min-max scale to scale it from 0 to 1. And then I did some reshaping of the data frame because we want to predict all the hours and the variables the day before. We want to use that to predict what temperature the first hour of the next day is going to be. That's why it has the shape like this. Then we needed to adapt the dimensions for the neural networks to be able to use the neural network. And this was done here for both the training and the test data. And now we come to my best performing model, which is using a very simple LS team layer as an input layer with 230 nodes. It also has one dense layer with 1 node. I'm using the cost function of MAE. And here an example when I run it. The runtime is pretty long, which is a bad thing, but it's weird because it's not that complex. But still, it's a negative effect of my model. Here you can see the analysis of the loss for both the training and test data of my model, and here you can see the analysis of some of the other models. Thank you very much for listening. Bye.